formal definition from yesterday. So if you go into your notes, we have to go back a page, and this class needs to, oops, I left all my work on there from last hour. We need to go, yesterday we did it wasn't this one. It was the one with the formal definition. It was on the bottom of this page. That's why I can't see it. I think there's, if I remember right, there it is. This hour we didn't finish part number 19 over there. And it's important. And it pops up on the AP test pretty frequently at this type, and it also is going to pop up on your circuit again. And you're going to get stuck. By the way, if you get to number 10 and you're not doing a table derivative, your circuit's off. We are going to go take a look at number 19. I was in the process yesterday of collecting the answers I saw when I walked around the room, and I was seeing all of these. So I just want to make sure, I don't know, I don't even remember who had what. The correct one is up there. So remember the formal definition for the chain rule? I'm going to go put one similar to what was on your worksheet yesterday. Remember, you do the derivative of the outside function first. So this would go immediately to cosine, correct? So when it's f of g of x, you do the derivative of the outside first. So it gets written formally as f prime. And then I told you leave the guts intact. It's the inner box or the inner link. So the first part of it looks like this. If I actually knew what the functions were, it makes it easier because I just go, well, it's cosine 2x, right? And then I do times the derivative of the guts. What's the derivative of the guts for this guy? 2, so my answer is just 2. The derivative of the guts for this guy is g prime. Yeah, this is what you needed to do at x equals 2. So on your circuit today, it's all going to be on a table, but it doesn't really matter how they give it to you. You just need to go find g of 2. Up here, that's 3. And then you need to do f prime of 3, which is 4. So that first thing's a 4 when you follow it this way. Today on your worksheet, you'll be following it on a table. And then you do g prime of 2. And g prime of 2 was negative 2. So the people who had negative 8 yesterday, you were correct. And I saw it, but who had it? I saw a negative 8 someplace, but there weren't a lot of them. So keep that in mind because it's coming back at you. So today, we're going to up the difficulty quite a bit with the chain rule. So if I did a whole bunch of them, it'd take forever because they take longer. So I do only a few, but I do them slower than normal. I'm normally a fast talker. I'm going to talk slower today. So we're going to go right in and start at it here. First of all, when you're doing this one, we're going to have different derivative rules within the same problem. So when I first look at this guy, I first and foremost see a product of two functions. So what rule do you think I'll launch into first? Product. Yes. Do you remember what product rule is, Paige? Like, what does it say I do if I'm going to launch into this using the product rule? Sure, and she's got that down. She should if she's done her homework authentically and didn't copy keys, right? You did it 10 times the other day. So first, d second, but while you're doing d second, it's a chain rule problem, correct? It's a function in a function. So from yesterday, we bring the power out front, don't touch the guts, drop it down 1, and then times the derivative of the guts. What's the derivative of the guts for this one? What would be the derivative of those guts? Go ahead. Yeah, you can talk when I have the headset on. I'm sorry, it always ends up your hour because I forget to put it on during the day. And I do have all my notes recorded from previous years, but I've kind of changed things this year, so I'm re-recording. Anyway, so yeah, this would be a 1, but be careful, had that been like a 7x minus 5, you'd need to multiply by a 7. So I am going to put times 1. So Paige, you said first d second, which I just did, and then I have to do plus second d first, all right? And d first would just be 3x squared. So that kind of fell out nicely. That's not where the issue is. Be very careful though on your circuit. So again, you have the benefit of being my last hour today. Some kids have been approaching this with the product rule. First d second plus second d first, and it leads you way off circuit or you get stuck if you can't find it. That's not a product of two functions. What is that, guy? What is that? It's a function in a function. That's yeah, it's compound function. That's funny. Anyway, this would be chain rule only. It'd just be cosine x squared plus 7 times 2x. Do you see the difference? Now the minute, Bodenheimer, if you see this, now it's a product of two functions. So be very careful. All right, so let's go wrap this one up. The whole reason in Unit 0 we spent some time factoring weird ones was for this section, to be honest. This factors, what can I take out of both terms at a minimum? Yeah, x squared for sure. So we're going to take that out. Also, what can I take out at a minimum? Go ahead and tell me. How about anybody? X minus 5. And then to what power? How many? I know you can see it, but I want to stress because on the circuit they're going to get a little uglier. So I always take out the lowest power, whether they're fractions, negatives, negative fractions, it's always the lowest degree. The what? So if you have a third and a negative 2/3, which one do you pull out? Negative 2/3. It's the smallest one. All right, so this one, it's obvious, but sometimes when they go negative in fractions, people goof up. So I can take out the x squared out of both terms and some x minus 5s. I then put beefy brackets down. So you understand that like we did in Unit 0, you'll need to clean up in there. This guy still needs another x for the x cubed and another 4. That's good. Then I need the link, and this guy needs the 3, and what else? Because I'm good with the x squared, I'm good with this. What else does this one need? How many of them? Now, because it's obvious, right, Christian? But I say that it's obvious, and then when I go do one where I'm pulling out negative fractions, keep in mind that to get that, you do big minus little. Obviously, it's 1 because this one's easy, but when this becomes a 2/3 and a negative 1/3, then for some reason that gets kind of messed up. So if you put the beefies down, it's going to force you to clean up in there. So we'll just finish this off with an x squared times an x minus 5 cubed, and then clean that up and soften it out as you do so. So what would I get? 7x minus 15, correct? And then I'm going to tell you something else. Leave it factored. What did I just say? Leave it factored, because our end game with this in Chapter 3 is going to be to use that derivative for a purpose, and that purpose is usually to figure out where it's 0. And I can see that right now. 0, 5, and what do I have? 15/7, right? So leave it factored. 1 down, all right? Next one's going to be a little trickier, but not too bad. Whoops, I have it all on here from last hour. Got to clean the screen off. So what rule will I launch into before I even, God dang, come on. What rule does this one go to first? Above and beyond all other rules. Go ahead, tell me. It's a quotient of two functions. So I am going to launch into quotient rule right now and then see what happens. So do you remember the quotient rule, Abby? Let's do it. Low. By the way, write it with the fractions. It makes your work easier. So when it goes radical, go fractions to work with it and then go back. So that's low D high. D high is just 1 minus high. What am I going to use, Kellen, for D low? Yep, and how do I take that derivative? Derivative of the low function. No, it's x squared plus 4 to the 1/3 power. How do I take its derivative? Chain rule. Yep, chain rule it for me. Perfect. Perfect. Almost. Perfect. And thank you for remembering the guts, because that's also been an issue today. People are like, oh, I forgot the derivative of the inside. So that's super important. I draw a line and I'll square below. So when I square that, it's going to become x squared plus 4 to the 2/3 power. This has got a bunch of things wrong with it because I've got fractions within fractions. I've got negative exponents. It's pretty much a mess. So I would deal with this piece of the mess because it's the messiest part. So we're going to go deal with that guy. So we have x squared plus 4. And I'm trying to not go too fast, but still try to catch you up to the other hours because I didn't have to do that one problem with them. So Sam, I'm leaving that first part set, but when I go over here, I'm going to have a 2x squared on the top after Kellen did that chain rule on that guy, and then I'm going to have the 3 on the bottom, and then I'm going to drop that down because we don't leave negative exponents. But the minute I put it over what Benzie said, all over low squared, I end up with this. If you're doing a circuit today, you won't find that for sure. What rule is it breaking? Am I going too fast or am I good? I'm good. All right, what rule is this one breaking as far as leaving things simplified? I can't leave a what? Go ahead and tell me. Can't leave a what? Complex fraction. How do I clean up a complex fraction in here? Yeah, do it that way. Somebody this morning said multiply by the LCD. I'm like, oh, that's so messy for this kind. So usually just go ahead and it's painless if you just crisscross applesauce. Be careful on this part though. Lizzie, what do I get when I do the first criss on there? Yep. Times what? The 3. Yep. So you just add the exponents, minus 2x squared, all over. How are we doing? Are we good so far? It's messy, right, Clausen? It's not pretty. But criss minus cross over multiply across. So I'll do 3 times x squared plus 4 to the 2/3. Then what did I say you do for this the big fraction bar? What happens? You go crisscross, multiply across, and then what? Multiply by, yeah, it collapses as a product. So no need to write it as the reciprocal. Just go ahead and throw her down here, right? As long as your algebra is solid, you should be pretty safe today. And then clean up the top and the bottom. So it looks like I have an x squared on the top, right? And then a plus 12. Watch my arithmetic, but that feels good, right? And then on the bottom, when we multiply, we add our exponents. So we'll have x squared plus 4 to the 4/3. On a scale of 1 to 10, yesterday we wouldn't go beyond 6. I call this one a 7. We got a little messier, right? Lindsay, are you ready for another one? You ready? Okay. Almost the last one. So now when I need to take the derivative on this guy, Lindsay, what rule will I apply first? What rule is this first? Yeah, it's a function in a function. And it gets sort of messy, not too bad. It gets sort of messy because when I leave the guts intact, really what I'm doing is f prime of g of x. That's what I just did. But then when I do the derivative of the guts, Robbie, what rule do I need to do? I do. So I just have to be a little careful. I have to do my low. And I'm assuming you guys know your quotient. So I'm going to do my low, my d high, minus my high, and then my d low. You guys watch me for arithmetic. Draw my line and square below. How's that, Robbie? Did I do good? You can never have too many parentheses. That's my rule. Right? Fairy, you ready? You won't see this on your circuit because we're going to leave it always all factored. No complex fractions as a single fraction, right? So this has got some issues primarily with this one, so we'll just kind of clean the whole thing up in one big chunk. So looks like I have 3x squared minus 6x squared. So I'm going to leave the 2 and the 3x minus 1 on here. Those are good. And then it looks like I'll have a minus 3x squared, right? Am I good? Then I have a plus 9. It's not going to go with anything. And a plus 2x. So I'm just going to go like this. You okay with what I did, Fairy? Yep, I just dumped it in, cleaned it up, all over, and then I multiply on the bottom. Here's something to watch out for. 2 things. One of them, always leave your answer factored, so don't start multiplying this top out, because our end game is usually to figure out zeros. I can see one right away at 1/3. Does that make sense? So don't multiply it out. Here's also what often happens when you're looking at keys or on the AP test. Sometimes, let's go do that. Sometimes they'll take and pull the negative out because this is kind of considered bad notation. So here's what you're sometimes going to see. I'm just going to do it in one full swoop. You don't need to write it in your notes, just watch. They'll pull the negative out front and you'll think that all of your signs are off. It's going to happen on your circuit on one of them. You're going to go, what? All my signs are off. And you'll notice that they actually will pull the negative out front or might even put it down here. Fair enough, Clausen? So that one's done. By the way, do you guys know how to tell if this thing factors without trying to factor it? Do you know a quick way? Has anyone ever taught you a quick way for knowing if a quadratic factors without like doing a discriminant or trying to factor it, or do you just try and you can't, so you know it's not? Here's a quick little way. And it can work for any quadratic. If you multiply these two and write it down, and none of their factors could produce a -2, the only thing that really goes into 27 are 9 and 3, and there's no way of getting the middle term, you're done. It won't factor. So that's a really quick way, instead of struggling going, well, I'm not quite sure if this thing factors. You go to 18, think of things that go into it. 2 and 9, I can get an 11 out of, so it might just factor. Anyway, just so you know. Next one up, we're not doing these. We did them on the worksheet yesterday, but circuit issues are going to happen with number 6. Go ahead and write 6 here, because when you're asking me about it, I'm going to say, go look at your notes. I did one just like it. 6 was a hurdle, 7 was a hurdle, and 10 was a hurdle this morning. So I'm going to put one almost just like it. On the circuit, there's a 7 right here, I think, or a 2, I can't remember exactly. And then there's a square root of either x squared plus, the 2 and the 3 are 2's and 7's on your circuit, but it falls out almost identically to this one. So first and foremost, what rule is this? What do you think you're going to launch into, Harvey, of all our rules? This is product before I do anything else. Exactly. Now, if I take off the x right here, then it's actually just chain rule on this piece. But this is a product of two functions of x. You are correct. So let's do first. Harvey, what would d second be? Can you kind of do that in your head, or? Perfect. Perfect. And I'm waiting for you to say one more thing. Something that caused this to be an issue. Times the derivative of the guts. So times what? See how that happens all the time. So be very careful with that. Then Nate, he did first, d second. I'm going to do plus second, but I don't want to mix my fraction representations with radical representations. It makes it really hard to work with. So I'm going to go all fraction. I usually do. If you want to go all radical, do that, but don't do both. So I'm going to call that second like this, d first. Are we good so far, Alejandro? So you get the next question. I'm going to clean it up just a tiny bit for you. So I'm going to go gone, gone. Let's go with 3x squared. Let's just do a quick rewrite. Just wait, Ollie. I do have a question for you. Don't leave me now, bud. Are you with me, y'all? Are you with me? All right. Are you ready? So there it's sitting there. What do I do now? Because it's got negative exponent. And it's actually a sum of fractions, which we don't leave because if I put that in the bottom, what do you think I'm going to tell you to do with that? If I put it underneath, I could crisscross multiply across. It causes more cleanup than doing something else. Can somebody tell me what the something else might be? It's from chapter 0. Factor it. And if the answer falls out really nicely, as long as it turns out nice and clean and ready to roll. So you just have to be very careful what you factor all. What can I for sure factor out of both of these? 3 no matter what. What else? I'll stick with, yeah, now what power? Why -1/2? Because it's smaller. There you go. Then put some beefies down so you know you need to clean in there. Right? And then put in what you need. You'll need the x for this one, right? I already have I actually need x squared, don't I? I need the x squared from that one. I've got the 3, so I know I need some x squared plus 2's. How do you decide how many? You subtract the exponents. What's 1/2 minus -1/2? I need one of them. So I'm not going to put that on there. Then you clean up in the beefies while also maybe cleaning the rest of it. So I'm going to take and put that down on the bottom as a root because that was its original representation. So that went down there nicely. And then I just have 2x squared plus 2. What might you see instead of that on the numerator? What might happen on the numerator? I might factor out the 2. So you might see a 6 times x squared plus 1, but I'm not going to rewrite that. Notice how this right here, the original answer that Ollie got me before I said start, it looks very different than the final one. So be careful with jumping around on your circuit. We're nearly done. I wanted to be done with 20 minutes to spare, so I think I'm going to make it. All right. So on this guy right here, it says find the values for which the derivative is 0. I want you guys to, let's go take and write the derivative. All right, so what rule will this be when I take the derivative? How about Al? Listen. It is a chain rule, Allison, right? So I bring the power out front. Al, I drop it down 1, so what will that make it? I'll step back. Perfect. And then I don't forget what? Perfect, which is? You've got a long question. All right. So power rule, pretty much done. I have a 4x on the top, and I have a 3 and a cubed root of x squared minus 1 on the bottom. Now I'm going to answer the questions and ask you a deeper question. The question was, for what values is the derivative 0? A fraction cannot be a 0 unless what happens? What has to be 0 for a fraction to be 0? What do you think, Nathan? Has to be, and the denominator can't be at the same time. But yeah, the numerator has to be 0. That's really easy. F prime will equal 0 at x equals 0, and 0 doesn't cause an issue on the bottom. So I want you to think about what's going to happen when I hit graph on my Desmos, because I have it loaded. What happens, do you think, when x is 0 if my derivative was 0? Think about that. Slope of the tangent line. It's easy to lose track of what we're finding now with all these rules. What do you think is going to happen on the graph? What'd you say? Not quite. It just means that the tangent line is horizontal. So what's your guess might have happened for the curve? Just make a guess. I'll take anybody. What do you think, Bo? If the tangent line's 0, what do you think might have happened on the curve? Yes. The function will change directions, and watch my pen. In order for me to change directions, what do I have to do? Have a what? Max or a? I'm going to have a max or min there. All right. It's possible that there might be, it might look like this that we call a plateau. That you'll learn how to figure out in chapter 3. But the derivative is 0. Where's the derivative not existing? That would be where the denominator equals 0 and the numerator doesn't. What's causing my denominator to equal 0? X equaling what? Go ahead. Give me one, Jake. 1. What else? -1. Yes. So think about what's going to happen on the graph. All right. If the derivative doesn't exist, there's 3 cases. The function was either not continuous. This doesn't have any issues. Right? There's no asymptotes, there's no denominator, there's no holes. This is good. So that's out. What other 2 things happened for a function to not be differentiable? You did a whole Desmos on it, but you did it graphically, not with the math. A cusp is possible, and one other thing, either discontinuity, a cusp, or what else? Do you remember? A vertical tangent line. All right, now I already did that. So either what's going to happen, you'll figure out exactly, it's either going to have a vertical tangent line or cusp out. So watch the graph. You shouldn't be surprised at what it looks like because your math was so good figuring it out. It should look pretty, on my Desmos, it's the red one. So you can see, here's my horizontal tangent line at 0. Super important for word problems because this gives us maximization, right? Right here, see the cusps? So it kind of fits. Go find the derivative of the next one down here. Don't worry about part A. I want you to go do part B. And how did I know you're supposed to find the derivative when it doesn't say to find the derivative? Go ahead and read it. Slope of the tangent line, that's what a derivative is. So you guys go take the derivative for number 2 for me, and then we'll talk about what happens on the graph of it while I pass out your worksheet. I was hoping for 20 minutes. I got there, and I had to spend more time catching up from yesterday. Did I talk too fast, Devin? No? All right. Well, then I caught us up. We were a little behind in here, but I caught us up. So go on that last one, says slope of the tangent line, which means find a derivative. It's a pretty painless chain rule derivative. Yours is right, Clausen, so I think have I picked on you yet today? I don't think so. I don't like to, sometimes the people who sit up here I tend to call on more, so I try to head to the back quite a bit. But I think I got Kellen, Ferry, and Lizzie all in today. Tate, let's do you instead. Head to the back. Otherwise, I'm a front row bigot, right? So I lost the question because my smartboard's being weird. But what was your derivative, Tate? Let's see if you got it right. Does that sound good, guys? It feels good from my other hours. You were supposed to show that this is what? Positive, correct? Are you convinced this is positive? This over this? I am. So that's right, greater than 0. It's actually greater than 0 for all x except 1. In part A, we would have had one number we need to throw out of the domain. So for part A, the domain isn't like it usually is in Algebra 2, all reals, but it's close. All reals except, go ahead and look at it, 1/2 would break it. So our domain would be negative infinity to a half union. So this is for all x not equaling to half. Let's talk about what this graph is going to look like, and then I'm done. Because there was an issue at 1/2, you should know what kind of an issue it is. It caused an issue in the denominator that didn't cancel. What's going to be sitting there at a half graphically? A what? Issue, oh, an asymptote. Yep, what kind? Vertical or horizontal? Vertical asymptote for sure. Plus, because Tate's derivative truly is positive everywhere, and that's the slopes of the tangent lines everywhere, what do you think the function's doing everywhere? If I were to walk on it, how would I be walking if its slopes are positive everywhere? I'm going to be walking uphill. Yeah, the function will be increasing everywhere. So I already graphed it on Desmos so you can see it, but I like to have you see what you're doing graphically because that's our next chapter is a lot of graph interpretation. So it's the blue one. Whoops. Come on. Do you see a zoom out? I accidentally hit my hand on it. Oh, whatever. Well, you can kind of see it. Here's the asymptote at a half, and it's going up everywhere on this side, and on the other side, it's also going up. So that's as good as we can do. I'm done. So for the circuit, super specific directions for your circuit. I passed out the wrong sheet. That needs to come back up. That's tomorrow. That is not the circuit. Sorry, we need to trade. I had these sitting out because the PSAT people need to pick them up today. So if you're taking the PSAT, hang on to it. Is that just for juniors though, right? And is it just in the morning? So you guys should be fine. My morning first and second hour had to come in and pick this up. So sorry, take that back. Extra credit would be by Monday. Yeah, and I did post some help videos for that. There's a couple hard ones in there. So circuit has to get done on a separate sheet of paper. What did I say? It's not optional. Right? It needs to get done on a separate sheet, and I'm going to tell you how I grade it. The next 2 assignments are very crucial to kind of being able to move on in here. So when that happens, I grade them a little differently. I actually grade them, and instead of just putting them in the 10% homework pool, guess where I put them? Just to make a little more bite to it. Where do you think I put it? Test pool. So it's great for those of you who make sure you ace it. It really helps that the grade. However, I don't post keys in that situation. So for the circuit, that's why I purposely chose a circuit because the answers are on here, but I kind of want you to do it. Be careful of doing it and go, well, I know it has to have a secant in it, so there's only one left, and hopping to that one and not actually doing the problem. Because I know that happens with circuits. I don't want it happening with this one. So I won't ever grade the answer. I'm going to pick 5 of them. I'm going to do 2 points. I might grade that you did the product rule and that you cleaned up your beefy brackets right. Or that you started with quotient rule and then you factored it correctly. So I'm going to correct 2 steps in the process to get to the correct answer. Does that make sense? 10 test points. So that's awesome. You can make sure you ace it because you'll know if you're doing it right. And if not, you'll have 93 of you of which to talk to. Feel free to do it with people. I kind of think of them as like take-home tests that you should ace. Because if you're stuck, text your friend who's in here and say, well, how do you do it? And if she says, oh, the answer's 4, you say, no, she's not correcting the answer. How do you get the 4? I want you to get to number 6, though, if you can. 6 tripped people up. 7. Was 8 bad? You started it already. think it was 6, 7, 10. 8 was okay. And then there was actually a hint I'm going to give you for, once we start getting to number 6, I'm going to give you a hint for number 7. And I think you might have missed, did you work? I'm going to turn this off. I'm sitting here chatting with you, I'm recording.